up this afternoon with one of the world's leading manufacturers of high-precision machine tools, DMG Mori, on how they're transforming their operations with the same rigor and innovation that defines their products. So leading that effort is Kentaro Blumenstengel, Executive Officer at DMG Mori and President of Technium Co. Please join me in welcoming Kentaro to the stage.
Hi, hello everyone. Thank you for joining my presentation. As already introduced, I'm from DMG Mori, the machine tool manufacturer. We are just next door, so if you have interest in our machinery, please, you're of course all welcome to visit our showroom as well. So today I'm going to speak about our experience with Tulip in our manufacturing. So normally when I make whole presentations, I normally speak about our products. But today the presentation is of course mainly about Tulip and how Tulip helped us as a company to transform our production. So I will make it very brief, so I promise I will only speak about 3 to 4 minutes about DMG Mori, but I guess there are some people who don't know our company, so I will just make a brief introduction. So our company was founded in 1948, originally in Japan, Nara, as a machine tool builder. So in post-war era where the Japanese manufacturing was rapidly growing, the Mori family decided to start a machine tool building company. Now, a few years later, we are now 13,500 people worldwide with a revenue of about $3.8 billion US dollars. Our headquarters is in Tokyo, but maybe you can already guess from our company name, we are actually now a joint venture between originally the German company Gildemeister and Moriseki, the original Japanese company. And that's why next to the Japanese headquarter, we also have in Germany headquarter in Bielefeld and many factories all over Europe. So here, just for your, maybe also there are some people who have never heard of machine tools. These are the machines we produce. I guess everybody heard of machining centers or lathes. But of course, this technology has developed over the last years, over the last 50 years, and we now also have metal additive manufacturing or laser cutting machines, ultrasonic cutting machines, so wide variety of machines to process metal and produce precision parts. These machines of ours are produced in 17 factories in over 7 countries. We also have a production facility in California, Davis, but the main factories are especially in Germany and in Japan. And the factory I'm also in charge of for the product management is the Iga campus, which is our main factory in Japan. And today I will especially be talking about our Tulip activities in this very large factory. Another big main point about DMG Mori is that we have a global direct sales network. So all our customers worldwide can receive direct support from our sales, service, and engineering teams in 88 countries from 116 locations. So maybe that's a very unique point. Most of our competitors work with dealers or agents, but we try to solve all the problems of our customers our own. So next, I will be speaking especially about our digital transformation activities in the Japanese facilities. I highlighted especially the Iga campus in blue here, so where we produce especially horizontal machining centers, turning centers, and mill turn centers. So these are maybe a few of the most representative machines in our group. And in the Iga factory, we do production, so also machining parts for these machines. But I would say the main manufacturing of machine tools is assembly. So you can say that also many of our use cases, I will introduce some of our use cases, are around and surrounding assembly. Yeah, and maybe as a last slide, introducing DMG Mori. So we have also, I think Nathan talked about digital transformation or continuous transformation, as he coined it today, in the manufacturing industry. But we as DMG Mori, we see also the digital transformation topic a little bit different from a purely machining or a precision manufacturing point of view. We see that this transformation, especially in machining, has to be a little bit more holistic, integrating the mechanical engineering. So we see as the new transformation in this industry, integrating like process integration, and then of course robotic automation, and then covering this all or supporting this all with the digital transformation. So from our point of view, of course, our customers are mainly doing precision machining. So that means to cover the machining and automation optimization, we need digital tools. And most of the digital solutions we bring to our customers are more or less in support of these optimizations of machining. And Tulip is, of course, one of the tools we use, or we also utilize as a core part of this digital transformation for our machining transformation strategy. So maybe this is a bit in detail, but I will begin by talking a little bit about our general journey at the IGA factory for digital transformation. What were the core elements of it? And then I have some use cases from different areas in our manufacturing, machining, assembly, of course, quality, and then information flow, and finally material handling and picking. But I think the beginning, explaining what the core of our digital transformation journey was, is the most important part of this presentation, where I would like to spend most of the time. So first of all, maybe to give you understanding, as a OEM of machinery, we have in our company, of course, as an OEM, we have two chains of production or manufacturing. So one is the engineering chain. Here we called ECM, engineering chain management, and then we have the supply chain management, SCM. And what this means is that when on the one hand, we have the engineers who are developing the machines, coming up with the design, and then considering how these machines should be produced. On the other hand, we have the production engineers who consider how the production process looks what it looks in detail. And because these two different chains have to work in alignment, this is always a huge challenge as an OEM. And here, Tulip played a very big role in transforming the way we do things at DMG Mori, because we were able to bring in the BOP, the bill of processes. So when the engineering chain management team develops a new product, they create a bill of processes. So the processes to produce the product. Normally, in many manufacturing facilities, the bill of product is just a document that is produced and created in the beginning, but it's like after it's produced once, it's never updated because it's very difficult to update this kind of document. But by combining or bringing in the bill of processes into Tulip, we are now able in our manufacturing operation management to fully have a living bill of processes combined with the MES and the resource management, which enables our continuous improvement of the bill of processes, and which made a huge change for us. So what did it look like when we started the journey with Tulip? So of course, it was not like we only used pen and paper. Already in 2020, we had some digital tools or software tools, of course. But what was the biggest challenge was that we had siloed systems. So we had point solutions surrounding the barcode handy terminal, which was maybe the record keeping of our production engineers. Then we had the quality management system, which was the tool for our quality management. And then we had the work instructions that were created by the engineer, so the machine design engineers. So all these systems were siloed, fragmented, and so it was very difficult if our engineering frontline found problems to update anything, because the update maybe happened in one of the silos but did not communicate to the other silos. So now we created, with the help of Tulip, we created a much more integrated system where every system is talking to each other with Tulip at the core. So, I mean, of course, this is still a complex picture, and I guess we still have a very high complexity in our production. But as you can see, so on the left side, we have the core systems like our ERP systems, our HR management, all kind of enterprise-level systems. And on the top, we have where especially our design team works. So, of course, you have CAD systems for product design. And then you have the production engineering, where our machines are programmed to produce the parts that are needed in the machine tools. But then when it goes to the shop floor, until now, there was almost nothing. So because on the shop floor, the people had very rough instructions, and the instruction, and the data at what was happening at the shop floor could not be monitored. But with Tulip at the core now, we are able to continuously create applications that transport the information or the plans that our engineering teams came up with to the operation on the shop floor. And even further, we are focused very much on integrating all the tools that our shop floor employees are using to directly communicate into Tulip to record everything that is necessary to continuously improve our production. And then, of course, on the right side, these are, I would say, the points we still have to work on to improve. So there are certain legacy systems, like, for example, tool management and consumable management on the shop floor. We actually have, this is more or less like a checklist, because we already know with Tulip and maybe some other also tools, we are able to move them out of the legacy step by step and turn them into much more platform-oriented systems. So, so to give you an understanding, so this picture on top shows that the whole process chain is now on the top. Of course, we have the core systems, but now everything is traced on the shop floor, on the front lines with Tulip apps from the logistics where our suppliers, the products from our suppliers come in, to the inspection, then to the assembly, quality management. Everything is like traced with Tulip. And for us as a company, it's very important. So we have certain operating principles. So I think they are very typical Japanese manufacturing thinking, or lean manufacturing, of course. So of course, all the processes we do should be standardized. So we try to not have any unique processes. So we try to standardize all the processes. Then all the processes should have built-in quality. So that means the quality checks, of course, there are some post-process quality checks included, but as much as possible, we want to integrate the quality into the assembly or manufacturing process. Then, of course, we need full traceability or trackability. And I think the last point is very typical, like Toyota-style manufacturing. So every time there's an alert or abnormality in the production process, we make sure that every abnormality is closed, and this happens all the time. There's no failures that stay open in the process chain. And on the right side, there are our new principles, more or less, that we learned with the rollout of Tulip. So that, of course, first of all, in the past, most of the IT systems, they came from IT vendors, from system integrators, but we are we have completely democratized the IT in our frontline. So that means OT has full ownership of frontline digital transformation. Then we tried to create patterns. What I mean here with patterns instead of packages is we are a relatively big company, so we want to roll out the best use cases or best practices to all our factories. But as we know, I think Tulip teaches this very well. No factory is the same. Every factory or every production is unique. This is also the case in our company. So production, even machine tool factories in Germany and Japan are quite different. And so we are not able to roll out the absolute same applications, but they are like patternized, and we try to use best practices that are then customized at the front line. Yeah, so which is like, of course, summarized in the sentence. So the center team builds the apps, and the sites then adapt how they are used. Another huge learning for us was that digital transformation process in a large organization needs organizational structure. So same as we have organizational structures for engineering, production planning, or whatever, the digital transformation also needs an organizational structure. And you can see here, especially with composable MES systems like Tulip, we need a strategy. We saw in the beginning, and I think a lot of, also I made the experience with customers. Often people believe that with composable MES you can start purely from bottom up. But actually this is quite not the very best way to move forward with this. I think it's a hybrid process. So on the one hand you have bottom up. On the frontline, apps are built or optimized, but you need a strategy from top. And so we definitely, I think, every digital transformation project needs an executive sponsor. And then that's why I want to explain why I made this yellow arrow here. So I think the most important department or team to create when you roll out composable MES or any no-code application in a manufacturing environment or through an enterprise, I think you need a certain steering team. And that's what we built in IGA, and I think which is also the secret behind our big success with Tulip, because this team has a very deep understanding of the applications or of the use cases, and they are able to continuously roll out or solve problems and roll out the best practices also not only to, inside of our factory but also to our sister factories or to our suppliers. So as I have been talking about success several times now, this picture depicts how we were able to roll out Tulip in DMG Mori since 2021. As you can see, we started, of course, everything starts small with 41 apps in 2021, which is now with counting, like this is a daily graph, so it changes quite rapidly, so that's why it's sometimes going up and down, because it shows the activities of the different applications. But we are now over 1,000 applications on the shop floor or stations, and with continuous growth. So we started in 2021 with a dojo, because of course, if you want to democratize IT, you need to teach the people in the front line. So we created a dojo where our Center of Excellence more or less taught the different teams about Tulip, how to build apps. And then the teams immediately after this phase started to build the apps, and we had onboarding on scale with all kind of in all different types of departments. And then the core department, especially in the phase 3, went into much more deeper or complicated use cases, because I mean over the time they collected all kind of experience. And then, of course, we also started to create more dashboards to monitor the success of this. And especially From this year ongoing, we are now, of course, which is of course the big topic of this operations calling, we are now trying to also roll out AI in our manufacturing. So just as a final slide about our overall experience. So one point that we thought is very important for our experience with this, and especially in a larger OEM environment, to have a very good BOP management, so the management of the bill of processes. So the bill of processes in the past, before we used Tulip, was always a document that came out of the product design, which described how a product should be produced in a very rough way. And then the production management or the shop floor had to read between the lines, adjust it, but normally this information was never fed back to the teams that designed the products. And with the rollout of Tulip, now the BOP has become really one source of truth, because the BOP is now shared. It's like a work in progress. So when the new product enters the production, we are now able to update the BOP, and we have much more standardized processes because there's no interpretation between the lines. So what I can recommend to, of course, a lot of what I'm already doing to a lot of our customers is to really, if you have a complicated product lineup, if you're designing products that are complex, to have a BOP will help you to roll out this kind of environment. So I will introduce some of the use cases. I have to warn you, some of them are quite complex, so maybe not that easy to understand. I will try to make it easy, but I try to I didn't want to take out too much complexity of these use cases, but because in the end, we are speaking about very complex issues. So I hope you can follow. So the first one is actually the most complex thing we did in the last 1.5 years, which is create a Tulip-centered tool management in our company. So in the past, tool management or cutting tools and machine tools are very important part of the machining process. And cutting tools are very difficult to manage because on the one hand, you have to, when you plan a production, you have to consider which cutting tools to use. And once they are under usage, you have to track how much wear has happened already. You have to track the cost of the cutting tools. You have to track the stock of the cutting tools. You have to get, of course, everything just in time. And, of course, they are also quite small in a big factory environment. So to know where they are and get them to the place where they're needed at the time is very difficult. And as you can see here, we had a very different data. We have several databases, all siloed, more or less. So there, as you can imagine, the searching for cutting tools, the information was never up to date. So people always had to find the information they needed themselves. So this is actually the most complex picture in my presentation. But what I want to show here is, first of all, how powerful Tulip is in integrating many different data sources. On the top layer, you see the connected databases. So we integrated the information that is going into the CAM systems. So when our people programming our machines, they have to know where are the tools, what kind of tools are available. Are there like tools we can immediately use from other productions? Then we have the material master information management, which is necessary for our procurement. Then we have to know what is actually, we have to communicate this information to the machines, because we don't want to manually input this into the machines. So we have to connect this to our machine tool management system. Then we have, of course, keep everything aligned with the ERP and MES. And then finally, we also have to align this with the bill of processes, because every time an engineer designs a part, he has to create a bill of process that also includes all the cutting tools. and how the cutting tools will wear off after producing 1 part, 2 parts, 3 parts, and this is like very complex. And by integrating this all into Tulip, we were on the one hand able to create an application for the people who program the machines, so they know all the cutting, the information about the cutting tools. On the other hand, for the people on the shop floor, getting the information they need to do the operation. And how this actually looks, this actually looks like. So if on the left, this are the 3 steps more or less. So on the very left, you see the people who we are now using in-house. We are using Siemens NX as a cut cam. So the people who are doing the cut cam can find all the tool data through Tulip immediately. They don't have to hunt down the tools, the tool information, and so the common operations for tool management was reduced like normal. Like, of course, this is an average, but like from 10 minutes to 30 seconds for a certain part. And then the resource. So on the other hand, we have. So UDE is a term from CutCam. So that the information that is necessary to update the CutCam information when a tool is already used or is a brand new tool is a little bit different. So this updating also happens now through Tulip. So if a tool is already used on one machine and then brought to a different machine, this information can be directly linked through Tulip to the second different machine. And then, of course, all this information has to be updated constantly into in the bill of processes, and this all can be done through Tulip. So why did we do this with Tulip? I guess you can imagine there are a lot of different software solutions for tool management. But as a company of our size, we actually compared a lot of specific tool management softwares, but we realized that actually none of those were actually just fit our needs. So our engineering team decided to build the tool management by ourselves, which was possible, of course, with the no-code platform. So, of course, the lesson learned here is, of course, that of course, sometimes it's better to use a specific tool, but if you don't find the answer, or you don't find the tool that the software that exactly fits your needs, then it's always maybe a good idea to build it yourself. And then, of course, no-code is the best solution, I would say. Another topic then here is inline quality. So in the past, our quality management was a lot of pen and paper. I guess this is not a very unique example. I think this can be seen at a lot of manufacturing facilities. A lot of quality information is collected on with pen and paper, and we transferred all of this into Tulip. And now, of course, this will enable us that we can see quality deviations in real time, because, of course, all this goes into graphs that are like automatically created, and so we are able to completely get rid of paper in our quality department in general. And I mean, we even made it a rule that there's no paper, any paper anymore, which was then, of course, we were able to do. So the next use case is assembly, which I will spend a little bit more time on because, of course, machine tools are, as I said in the beginning, assembly is the most important production process in machine tools. So here, one important point, as I already mentioned in the beginning, was the ability to bring together the engineering chain management and the supply chain management. Meaning that on the one hand, we were able to use our system that we use for the BOP management, so the bill of process management, to directly read, or that Tulip can directly read out of that system, so that when a designer designs the bill of processes, it is not only in his design software, but it will directly be broken down into a Tulip step-by-step manual for the operations. So this was a big game changer for us, because from that point on, the engineering chain management and supply chain management were completely aligned. So this was a really huge change. we are using here Fujitsu, a Fujitsu software called VPS, but I guess this could be done with any type of assembly simulation software. But of course, we recommend this to our customers all the time to bring this digitally in alignment, because as we see in many companies, if there's a divide between these two systems, you will never get full alignment between these two departments. Yeah, and then we were able to also, because the bill of processes then was in Tulip, and Tulip is a work instruction software that can be updated all the time, we were able to go much more into depth in creating like really small step instructions for our assembly employees, and thereby, as I understood last time, we measured like reducing the products that did not that had quality problems after installation by 75%. So this was a huge impact for us. Maybe this is the biggest impact for IGA by rolling out Tulip. And then, like, I think, of course, a lot of customers, when they come to our factory, the first thing they see is that all our hand tools are IoT-enabled, so that we, of course, as I said before, we removed pen and paper, but now we also removed manual input. That means by IoT-enabling all the tools that we use for assembly, for example, the torque that is measured by the torque wrench is directly written into the system, so there's also no mistake anymore by manual input. So, as you can see here, they just activate a certain process and then use the IoT-enabled tooling so that there's actually no input, just selecting the process. So just to go a little bit more into detail, how the more specific or detailed work instructions benefited our department or were enabled in the first place. So the first point was, before we had the model, and then we had the BOP, which was only a very high-level instruction. So the people on the shop floor had to come up with the idea how to produce, actually assembly the products themselves. But by combining this with Tulip, so as you can see on the after side of this slide, we are now able to see the light gray areas, which are in the assembly simulation software, and then the darker gray area, which is in Tulip. And by rolling this out on Tulip, our production management were able to create a new rule in the company that all work instructions have to be maximum 30 minutes. So there are 30-minute operation sets. By having these 30-minute operation sets, of course, continuous improvement is much easier because you have a certain time that everybody's trying to protect or stay aligned with. And then you also much easier can improve these 30-minute sets continuously. So as you can see here, this has brought a lot of different benefits to our factory and also especially to our products, which is like really, really highly beneficial. Yeah, and then maybe one use case I also want to highlight that is using a very new technology, and I think which is also a very important partner for Tulip, and we also were introduced by Tulip. This is zero key. So as you can see, of course, on a machine tool, this is a high precision machine. There are a lot of bolts and screws that have to be have a very specific torque, how they have to be fixed, and the torque of these used on these bolts have a high impact on the accuracy of our machines. So in the past, often it was the case that the torque and how the bolts were screwed in were very dependent on who was doing it. So it was very human dependent. And of course, if you would use robots, you could also improve this. But the point here is we still work with the same assembly employees, but now we are using ultra-wideband indoor GPS that can track in centimeter accuracy the 3D location of a GPS tracker. So what we do is we put like a GPS handbands on our assembly workers, and they when they screw, like as you can see here, they have an IoT-enabled torque wrench, and when they close the torque, of course the torque is recorded, but not only that, but the location that is currently closed is actually recognized by the zero key function, so that the operator does not have to do it in the right order. He does not have to tell the system which screw he's currently working on, but the system automatically knows where he's working. So to do this, we had to, of course, install these GPS readers in the factory, on a factory roof or on the ceiling. But by doing this now, we can also trace immediately exactly where the tools are used on and which bolts. So this is it's also a huge game changer for our for improving quality. And the next topic or use case will be inspection and quality. So I think this explanation will be a little bit more generic. Of course, in the past, quality inspections were mainly done by pen and paper. And here we used, of course, our experience with IoT. So DMG Mori has been doing IoT, I think also as like a front runner in our industry. And so what we did is with Tulip, of course, we are able to read out a lot of different data types from our machines. And in the past, when we measured these kind of different informations by hand and then recorded them on pen and paper, because of the ability to read out the information into one platform like Tulip, we understood this. It makes much more sense to add additional sensors to the production machines we have, because now the data can be directly read into Tulip tables. And especially, as I said also in the beginning with the other use case, this enables a trend line. So in the past, the trend line needed certain employees to do certain analysis, and the trend line was only visible like after like a certain time of certain work hours by our employees. But now the trend line is like for free, and we can always see that if there's a change in the trend of quality. Another point is our accuracy checks. So in the past, it's a very similar topic. So of course, machine tools need very high accuracy. So less than 10 micron accuracy. And to reach this accuracy, the axis of the machines have to be measured during assembly, before shipment, and in production, of course, they have to be measured again and again, like continuously. And this was also done by hand, more or less. The recording was done by hand. But now we are able, so we use linear guides to measure these numbers, and this can be completely read out of the machines. And we are able to create like a medical record of our machines, the accuracy of our machines, and which enables really higher accuracy machining than in the past. I think most of you, if you're not in machining, does not tell you so much, but alone in the time I am working in machining, I think I'm now active in machine tools for about 13 years. The level of accuracy has been changing like rapidly, and I think this kind of advancement really plays into it. Yeah, then the next topic is information flow. So this is more or less, I think this is not very machine tool specific. It happens everywhere. Of course, we had shift reports or failure reports from the shifts. But what we saw is that especially these error reports or problem reports, they ended up somewhere. Sometimes people worked on them, but nobody really know what is the status. But having this all now in one platform, we are able not only to record all the information that is necessary, but also the process in solving the problems. And not only, and also able to, because all our employees now in the production have a tablet, like a single employee has a tablet, so that they can also take pictures or videos and attach them to these problem reports. Another information sharing is the stock or the consumables management. So of course this is not the consumables management of the whole factory, but on the shop floor, on the front line. And what we see there is always, like you often see these white paper lists where somebody writes in what they took. But of course, this is not centrally monitorable. And what we change is now, you can see on the right side, I think there's a similar use case also in the Tulip showroom today. But we created, so to say, we created e-commerce for everyone. So there's like an online shop screen for every frontline or shop floor where they can manage their own consumables. And if they need something, the Kanban system is always real time, so that there's never anything missing. Yeah, and then the last topic is material handling and picking. So this is also, again, a very no-brainer solution. So in the past, as I said in the beginning, we used these BHT handhelds for our manufacturing people that told them what to do. It's like more or less a work instruction. But of course, they did not have a real monitor, like a real screen. And when they were picking parts or certain things for the assembly, the system just told them the numbers, and they walked around the shelves to pick up the things. But of course, with Tulip, we are now able to attach maps of our production facilities into all of the apps, so that the people picking up parts or assembly material are able to optimize their picking routes, and thereby reducing the picking time. I mean, this is, of course, you can say that does not make a huge difference. I'm sorry, this is in Japanese, but originally, like, we had, for example, 52 meters to pick up these 5 parts, but this was reduced to 35.8 meters. Of course, a small step, but nonetheless, this kicks off the next optimization, because we believe by using this, we are now able to, of course, consider AMRs, or automated robotic vehicles, to pick up. But this is only possible by doing this step in between of visualizing all the picking. So these are all the use cases. No, these are actually not all the use cases we have in IGA. We have many more, but this is only one selection. And they are continuously growing. This is, of course, only possible because we use no-code, low-code, and our OT engineers are now actually the biggest drivers of our IT. And so we are now considering what we should do next. And actually, what we are going to do next will be also a huge change to our company. So until now, of course, we were doing this digitization or digital transformation with Tulip on the shop floors for ourselves. So we taught our OT people how to do this, and they were doing it. But we feel like, okay, so we did it for quite a while, and to just keep the secret to ourselves is like really a loss of knowledge. So we are now considering to bring this to our, especially, of course, group companies that are not only building machine tools, but, for example, all kind of other products, and then bringing this to our suppliers. And then most importantly for myself also, to bring this to our DMG Mori customers. And of course, we can create a team as a service integrator, like any other service integrator, but by having this huge experience at the shop floor and IGA and our other production facilities, we are able to combine our actual experience on the shop floor with our service integrator knowledge and bring really best practices to our customers. And then, of course, this will also ensure that we are continuously improving ourselves by learning from our customers or the projects we did for our for external partners. Yeah, thank you very much. That's everything from my side.